So we are moving right along to our final keynote of the day. We have Dima joining us. Let's bring to screen. Dima is from Grammarly, and he is going to be here to talk about your platform journey.
Hey folks, yeah, happy to be here. Thanks.
Thanks for joining us. Grammarly is really cool tech. A lot of people talk about it. I'm calling in from Danielle's place in Massachusetts today, but normally I live in the Silicon Valley, and a lot of chatter about Grammarly. So good work over there.
Thanks.
Awesome. So
Cool.
with that, we will duck out and leave you to it.
Awesome. Yeah, so hey everyone, I'm Dima, and I'm gonna share with you today the Grammarly's platform journey. I've been working here for 7 years, all the time working on the platform. So lots of the stuff I will be talking about, I have experienced myself, and a little bit of what we're gonna cover today. We will go over some context and how it went from the time of the inception of the platform team at Grammarly, how we did our recent Kubernetes replatform, our stack that powers it all, and scale at which we operate right now, and some of the learnings to share with you. So let's start with a historical overview. And our platform team actually was built in around 2015 on top of the ops team, and that team was there to solve all the stuff that DevOps is at the methodology is there to solve. From that time on, our team was working on platform as a product to provide our engineers with a way of developing the services with the same DevOps principle in mind of you build it, you own it. So what that meant is developers all started owning the whole service lifecycle, from low-level infrastructure to building app to building alerts, being on call, respond to all of that. And we as a team were providing them building blocks to empower them doing that. So over the years, we added a lot of stuff for them to use, like Terraform, better monitoring, logging, whatever, using more AWS managed solutions, again, with the help of providing Terraform modules and all that stuff. But the next milestone of our platform would be 2018. And that was the time when we started to rethink how we deploy stuff here. So previously, that was an in-house built solution that wouldn't scale as fast as Grammarly was scaling. So we needed to find some sort of container orchestrator, because by that time we already have been using containerization a lot, and the same like in-house tooling was built on top of that. And we chose ECS at the time. EKS was like in a pre-alpha stage. We tested that out, and as our experience shows afterwards, EKS and Kubernetes in 2018 is a different thing than it is right now, thanks to the community and all of the things. And ECS started as a push towards implementing auto-scaling, that's the first thing, to adjust to the scale, and AMI updates to be able to do security patches of the underlying instances without disrupting too much of engineers' lifetime. So at this point, we took back ASG configurations, and we were in this like split brain situation where we manage some stuff like ASGs. Service owners have all that, everything else. Then moving forward, the next milestone was around 2020, with our team needing to support the security audits and certifications our company had to get. And we made our platform in the so-called infrastructure 2.0 thing, which meant we designed a new AWS organization and network. And by design, it was meant that one AWS account would be provisioned per service per environment, to still leave people with all of the needed creativity to do whatever they want in their AWS accounts, but without impacting other stuff. And by design, there was no cross-environment connectivity. And on top of that, over the several coming years up until 2023, we were adding more features and supporting moving to this infrastructure 2.0, and also trying to build more on top of that, like simplify and provision AWS accounts that it's like you get your own in like under an hour. Doing golden paths for the later service standardization and creation and maintenance. But all of that led to emergent complexity of the platform. So by the end of 2023, when we started to also, we had some evaluations of new features that we wanted to add, like service mesh, for example, or a way of doing pooling of metrics instead of pushing in this very distributed organization. We understood that we need to step back and think, should we do replatform and rebuild our platform with all of the known features we want right now? So a little bit about emergent complexity. When you have like two services, 2 accounts per environment doesn't make too much of a hassle. You just connect those via your transit gateways, and that's okay. But with more and more growth of the team and rapid development, it quite easily becomes a mess. So we ended up having around 300 AWS accounts, hundreds of applications, lots of teams, and lots of interdependencies that were, even with all of the automations, hard to configure. With that, having you build it, you own it approach also means that there is not so many centralization in terms of approaches or golden standards, because even if we do a golden path, it diverges quite fast. And it all comes to that it's hard to maintain support, and I would say most importantly on board too, because whenever a new person joins a company, explaining platform looks something like this. So that's where the prerequisites with which we started to move towards replatform. And in the beginning of 2024, we had several motivations for doing that. The first one, to abstract away infrastructure from developers and take away low-level infrastructure to more abstractions, and so that they can focus on feature development, but still have some way of saying how does their service run. Then enhancing developer experience. If we were to rely on a cloud native ecosystem, we suddenly get lots of documentation that was built by the community, and newcomers or even someone who joined the company in the past years could have already been using that. So there is less time onto adapting to a stack. And of course, some of the unlocked capabilities that we were searching for, like service mesh, doing ephemeral environments instead of having to like lock QA to test your changes, and even like doing something like a reproducible boxed homogeneous environment that, if needed, could be deployed to a customer cloud. So with all of that, we can move forward to what did we build over the course of 2024. Our stack is powered by AWS EKS. We use Helm charts that we write and test and provide to our engineers so that they impact how their service feels, looks, and runs. And Argo CD is used to continuously deliver all those configured charts of the services to our Kubernetes clusters. We also use Argo rollouts instead of the deployment objects so that we can have more robust rollout strategies. Carpenter provides instances, and we use quite a lot of GPUs, and having an ability to easily switch and expand the types of the instances that needs GPUs during like shortages hours was very helpful. Kata autoscales based on different parameters and triggers. We use Linkerd as our service mesh. We are adopting OpenTelemetry, but we are heavily using Victoria Metrics for metrics. And this is used as an admission controller, security tooling for security folks to see what's deployed and how it looks like running in the cluster, and doing fancy stuff like only deploying scanned images with no vulnerabilities to production. So coming to scale through building this platform in 2024, we have identified that our main goal for the first candidate to migrate would be our text processing stack. And our text check-in is actually around 80% of the compute Grammarly has. 20% is other services which are being migrated right now. We have good progress there, but our main goal was to do a shift and lift of text checking. So to power it up, when we switched the traffic fully to Kubernetes, we needed 6 identical clusters to scale out and handle the load without disruptions. We needed around 12,000 nodes and 140,000 pods to do that. And with this, we have some learnings to share with you while we were building the platform. So the first one is the most obvious for us, is that scale amplifies everything. When you are operating at scale and building the platform and using open source, you read blog posts, everything has its limits. And at scale, you are to find out those limits. Another thing is that we are quite used and confident to operating at our scale, so we weren't even thinking of some things as issues. So the first one we hit was that Kubernetes endpoints gives only 1,000 IPs for endpoint objects. And when we were ramping up testing traffic, we suddenly find out that we are going blind at some point because, once we are hit more than 1,000 nodes, the observability is being lost. So we switched traffic back, we implemented endpoint slices, moved on. And next thing is around 2,500 nodes, Kubernetes API started to become unresponsive. That led us to having 6 identical clusters to share the load and redeveloping it a bit so that it's pluggable and it scales infinitely with number of clusters. Another thing, once we were migrated already, was Argo CD that was in some sort of race condition when we had a mass upgrade of all of the services across all of the clusters, and continuously ephemeral environments were creating commits to the same repo that had the configuration of the services. So it had this race condition where it was syncing to a commit, but there are new commits coming up, so it was failing to sync that. So what we want to tell you here is that we need to test at load, switching traffic incrementally and having ways of rolling that back easily. And you should do that until something breaks. If nothing breaks, that's cool. But at some point of the load, there would be these problems in different components that you will have fun trying to narrow down. Actually, we have recently released a blog post about the actual time when we were doing the traffic switch and running 100% of traffic on Kubernetes. And one thing was actually happening only at peak hours at highest load. And it took a lot of time, effort, and a good team to track that down, fix it, and have a very scalable and reliable platform right now. The other learning is that one way to run everything is much better than having a lot of flexibility. So with that, consistency does turn complexity into routine. So for example, if you need to scale up all services during an outage, or you need to debug something and you have standard metrics and standard alerts around those metrics. And in case you're using open source, you have community knowledge, runbooks, and well-known issues that you can consult to. It all makes very trivial incident responses. You have same signals, you follow the same debug principles, you are adjusting same configs if that's needed. And if you fix something, it gets fixed everywhere at once. So here, currently we are in a process where we are moving more towards an SRE-led platform. So we are currently, our production engineering team is currently in that role. We are also hiring new SREs to switch over to that model, with keeping our engineers still to be empowered to contribute to Helm charts or test out something on lower environments if needed. Then another one, platform evolves with the growth and the growth of the company. So each new scale or challenge or business need needs a new operating model. As for example, we needed ECS to run auto scaling and do like AMI updates, security updates, like we needed infrastructure 2.0 to pass certifications. And then after hyper growth, we would need more centralization and less cognitive load on developers. So you need to constantly reevaluate the needs that you provide. And another big thing is that you need to secure buy-in, because just doing Kubernetes because it's hip is not going to work. And you really need to understand yourself why you're doing that. And as Liz said, you're doing the right thing at the right time. So yeah, that's another one. And the last one that we have learned over all of these years is that usually community power does beat DIY. We have a long history of doing a lot of things in-house, but recently we have proven that shipping with patterns that 1,000 eyes of community taken a look at, and with using right tools, beats doing that. Some of the examples, like when we were hitting the endpoint problems, upstream Prometheus didn't allow you to use endpoint slices as a target for scraping. Victoria metrics that we are using did allow that, so we could easily overcome it. Another example is Linkerd. During the stories that you can read in our blog post, we have been working very closely with the developers team to fix and debug all of the issues that we were having. Also, Linkerd empowered us to save a lot of money by eliminating ALBs and switching and keeping traffic inside one AZ using Hazel. So right tools bring a lot of values, and these right tools might be different for you. It's just a process of finding the right tool. So yeah, use community built tools, improve them if they don't fit your need, or open source something that you think will give back to community. Open PRs, contribute, and win time for yourself and others. Yeah, thank you. That's all I've had today.